There are three main properties of logarithms that you'll need to know and be able to use out of section 3. There are some problems in the section that we will not do. I think the purpose that they have for them is to try to kind of introduce the properties, but I think it probably does more confusing than anything, so we're going to jump right up to the problems and just do some examples with those. The first property is on page 520, and it deals basically with multiplication. If you see log base b of m times n, you can split that up into two logs with a plus in the middle. So you could write that as log base b of m plus log base b of n. So you use that property. Sometimes you need to go from the multiplication to the plus. Sometimes you need to go from plus to multiplication. Just know you can work that problem either way. So if you saw, log base 2 of x plus log base 2 of 6, you should know that you can rewrite that together as log base 2 of what? Right. Log base 2 of 6x. So that's your first property. The next one is division. And what do you think you can change division to? What? Right. Division and subtraction work together. So log base b of m over n, you can rewrite that as log base b of m minus log base b of n. And you can put numbers in that same numbers we had on this example here. Will work the same way. And most of the time you're going to be given the addition or subtraction part. You're going to put that together as one logarithm. Questions on those? The other one is on the next page, 522. It's the power property. You can log base b of m to the p power. So p is your exponent there, log base b of m to the p. You can bring that around to the front and multiply it. So it would be p log base b of m. Sometimes you'll need to move that the exponent from the front up and make it an exponent. Sometimes you'll need to move it out to the front. So you can use that either way also. So if you had log base 3 of x squared, you can rewrite that as 2 log base 3 of x. So then on page 523, there's a few examples there that we'll do, just illustrating how to actually use these properties in problems. So we have 3 log base 5 of x minus log base 5 of 4 equals log base 5 of 16. And of course, we'll still be using the rules that we've learned in the first two sections to solve these. So do we see any parts there that would become an exponent? The 3. So that would be the first thing you would do on this problem, is move that 3 up to where it is an exponent. I'll show all the steps. As you were writing down the problem, you could have probably moved that up there, and that's all right. So that becomes log base 5 of x to the 3rd, and the rest of them don't have an exponent. So what other rule do we see? What? Right, the minus becomes a division. So you're gonna rewrite this side as 1 log base 5 of x to the third over 4 equals log base 5 of 16. So how many logarithms do we have there now? Just 2. And going back to the previous sections that we've done, since you have the same log on both sides, you can set this part equal to each other. So x to the third over 4 equals 16. And how will we solve that? Times by 4 or cross multiply. Either way, it's the same thing. So we have x to the third equals what? 64. Then what? Cube root of 64 is questions? Do another one just like that one. 4 log base 2 of x minus log base 2 of 5 equals log base 2 of 125. So what do we do first on the last one? Put the exponent up. So we have now log base 2 of x to the fourth minus log base 2 of 5 equals log base 2 of 125.
How can you tell whether or not you're supposed to move the exponent to the side?
Because you're trying to get it down to 1 log. So by bringing that up, you're condensing that down to one thing, and then with the minus, you can totally merge it into just 1 log. Which is what we'll do next. So with the minus we have in the middle, it becomes log base 2 of x to the fourth over 5 equals log base 2 of 125. And then we can set those parts equal. X to the fourth over 5 equals 125. So we get x to the fourth equals 625 and the fourth root of 625. X equals 5. Log base 4 of x plus log base 4 of x minus 6 equals 2. What's one thing we see different? It's a plus, so what's that mean? Multiply. What else do we see different? Okay, what else? It's not what? There's not a log on the other side. It's just a 2 over there. So this problem will be a little bit different, but we have done problems like it before. So we already said the plus becomes multiply. So we're going to combine that to log base 4 of x times x minus 6 equals 2. and you would go ahead and distribute that to both parts. So log base 4 of x squared minus 6x equals 2. So in the other problems, once we got it to this point, we set it equal because we had the same log on both sides. We don't have that here. So what do we do? What? No, you can't change the log, or you can't just add a log to the other side.
You change it to the 4 by putting an exponential.
I think you're on the right track.
Can you put a lot of two on the motion?
It's stuff we did in the last sections. Last section, I think. What form is that in? Log. What form could we change it to? What? Exponential. How do we do that? What's your base? So we have 4. What's your exponent? 2. So 4 to the second equals x squared minus 6x. Remember, this to this equals that. So we have 16 equals x squared minus 6x. What do we need to do now? So we have 0 equals x squared minus 6x minus 16. What is x? So x equals 8 or negative 2. You do have to check these. And see which one's going to work. So if you were to plug the 8 in, for these x's right here, you would have log base 4. That would be 8 times 2, so log base 4 of 16 equals 2. Does that check out if you put it in exponential? 4 squared does equal 16. So 8 checks out. If we put negative 2 in right there, remember from last time, you can't have a negative in that part, so negative 2 does not work. 8 is your only solution. You can't have a log base anything with a negative number. So no matter what it is, you can't have this being negative. So by plugging in a negative there, you're making that negative, so that's why the negative 2 won't work. Log base 8 of x plus log base 8 of x minus 12 equals 2 again. So we're going to combine log base 8. You can multiply these two, and that would give you x squared minus 12x equals 2. Then what? Good. Change it to exponential. 8 to the second equals x squared minus 12x. What's 8 to the second? It's So we have 64 equals x squared minus 12x. Subtract the 64. X squared minus 12x minus 64. So what can x be possibly? 16 and negative 4. And which one will not work? The negative 4 again. If you plug negative 4 in right there, that becomes undefined. 16 is the only one. Page 524 and 525. Page 25 to 38.